right. Let's talk about the answers to the definitions here. Numbers such as 1, 2, 4, 5, 10, and 20. What do you think those go to? Raise your hand and tell me. Brighton. Yes, ma'am. Factors. How many of you had that? All right, 2. A number raised to the second power is a what? Asher?
Squared.
To the second power? Yes. Sorry, I'm looking at the wrong one. Yeah. Squared. What about a number raised to the third power? Third power. What do you think that one is? Ireland. Yeah, cubed. Remember that was a cubed, and this one here is squared like that. A way of expressing a composite number as a product of its prime factors. It's a little bit tougher. You did this one on number 6 and number 7. Ray. Yes, sir. Prime factor. Prime factorization. Numbers like 10, 100, 1,000, and so on. Colton. We've used squared.
Oh, no. Powers of 10.
Yes, sir. Powers of 10. Powers of 10, like so. How many got all those right? Vocab's usually tough for you guys, so I get it. Down here at the bottom. Some of us forgot how to do this from the first lesson since we're on lesson, what is it now? 6? Yeah, 6 today. 36. What times what equals 36, Lauren? Two times 16. I'll give you the 2. Ireland? 18. 2 times 18 is 36. Now, can we break 2 down any? No, so we're finished with that one. What about 18? What can we break that one down into? Surely Ireland's not the only one. Emmeline, or Asher, go ahead. 9 and 2. Well, I guess we circled that other 2, so we're good with that one. Can we break the 9 down more? Go ahead, Ireland. 3 and 3, and we can't break 3 down anymore. So now we have these numbers. This is where a lot of us, we did this. A lot of you understood that you do 2 times 2 times 3 times 3. But then it asks you here to use exponents, and that's kind of where it threw some of you off because we only really spent one lesson on that. So you take, how many 2's are there here? So you take 2 to the power of 2 times, how many 3's are there? How many? So 2. So you have your answer is 2 squared times 3 squared for that one. 45. What times what? Libby, did your group come up with one of these?
What?
Did your group come up with what times what equals 45 on your paper?
Yeah.
What is it? Ireland's like, we did. I saw it on y'all's paper, but I don't know. I'm hanging off
I wrote it wrong.
a cliff. All right, what is it, Ireland?
5.
Yeah, let's do 5 and 9. Can we break 5 down anymore? No. Can we break 9 down? Anybody, raise your hand. What is 9? What times what equals 9?
3.
3 times 3, yeah. Can we break 3 down any? I circle those because the ones that you circle are the ones that you're going to write up here. And I always start with the small one. So I start with 3. How many 3's are there?
2.
So 3 to the power of 2 times, we only got 1 5. So we have to write anything there? That's it. We're done. This one down here is pretty easy. We didn't have to do anything other than what's the answer to this one here and how do you say it? Emma. 13 to the power of 4, yes. What about the number 9, Sailor? 7 to the power of 3, yes. Good job. Turn it over. Now this one here, we have to write each product as a product of the same factor. So how are we going to write this one out first? Maddie, what do you think? How are we going to write this out? So she said 10 times 10 times 10 times 10. And now we have to multiply. Now, as I walked around the room, and I'm sure Mr. Crockett said the same thing, saw the same thing. How many times did you see they wrote down 40? Several wrote 40 down. Because you're adding again. Remember, exponents is not repeated addition, it's repeated multiplication. So get adding out of your head. So what is 1 times 1 times 1 times 1? Libby. 1. And Libby, how many zeros do we have here now?
4.
So we write 1, 2, 3, 4. And we go over here and we write 10,000 as our answer. Told you didn't need a calculator for that one. Remember, we did use our calculators to figure that out at one time. We said 10, and then we used this little, what was it, this one here, to the power of 4, and we get 10,000. All right, next one, 14 to the power of 1. Easy. What is that one, Emmeline? Wait, number 11? Oh, okay. That's all right. No, that's all right.
I put the thing, I'm gonna keep the thing.
You put 56?
Yeah, I don't know what.
I don't know how you got that, but hey, she came up with an answer. Somehow she got it, but we'll go with it. Mikey, what do you think it is? Yeah, it's 14. There's only one 14, so we don't multiply it by anything. It's 14. All right. You don't need to write that 1 ever. If you just have a number, that's it. All right, do these mentally. Mentally. Oh, let's get Gavin. Go ahead and do that one. 2,300. Is he right? You bet he is. All right. Let's do number 13. See, I have it called on. Yeah, Holly. 60,000. Yeah. And here's the thing that some of you, I noticed one group did. 15 times 4 is, go ahead and write down that 0, 60. Now you look at the zeros that are left and you got to add those also. 1, 2, 3. That's where she said 60,000. I think a lot of you are going to have that error if you do that on a test. I think it was Emma. I think Emma's like, she wrote 60 down and she's like, well, I need to put 2 zeros down. No, you still need to put your 3 down, 3 zeros. The amount of space in the dog carrier shown can be found by multiplying its width, length, and height. Write the amount of space in cubic units using an exponent, then evaluate. So we got 2 things there. We have to write it as an exponent and we have to find the answer. So Asher. Is what? 2. What do we put up here? No, when we're doing, I guess it should have said volume is what they're trying to find. So we're only multiplying 3 things here. This 2, and this 2. So what do you think the number is going to be up here if we're only multiplying 3 things? A 3, yeah. So that is going to equal 2 times 2 times 2. And what is that going to equal when you do 2 times 2 times 2? Emma? Well, we got that right here. So when you multiply those, what do you get? 2 times 2 times 2. 8, and we're not done yet because this is in feet. And guess what we put next to the feet? Cubed. Because we multiplied 3 feet together, 3 of the foot markers. There are 10 to the power of 2, or 10 squared, 5th graders attending a class field trip to the art museum. If each costs $6, what's the total cost of those students? See, so what's 10 squared even equal? Ollie? 100. 10 squared, you guys should remember, we have the 1 and we have 2 zeros. So what is 100 times 6? $600 they spent. And then the last one, Dakota read 130 pages over the weekend. Dewan read 165 pages over the weekend. Which prime number do the prime factorizations of 130 and 165 have in common? So I think I told you this once before. I said if it ends in a 0 or a 5, are you going to have a 2? No. Are you going to have a 3? Are you going to have a 5? Yes, they're both going to have 5, right? So your answer is 5. If it ends in a 0 or a 5, 5 is always going to be a factor. Always. Okay, you guys can put that to the side now. If you would get out pages 113 to 118, give me 117 and 118 with your name on it, please. All right, so lesson 6, pages 113 to 118. It's a hands-on, and you're going to be using the little thing called partial products and distributive property. Now, the reason why we do this is because we're eventually going to get to multiply double digits. So we're going to be doing things like, say, 12 times 26. Okay, we're going to be getting to that. Now, in 4th grade, you might have had that, depending on who you had. I think we started to, I believe. I'm not 100% sure. But you guys will be getting to like 236 times 12. Things like that, okay? So we need to talk about partial products and using this little thing called a distributive property in order to figure out what we're doing here. So Darnell and his 4 friends went to an ice skating rink, and they bought sandwiches. That makes sense, right? They're buying sandwiches. They're hungry. They're at a skating rink. So they divided the total cost, and they found that each person needs to pay 17 bucks. What was the total cost for ice skating and sandwiches? Okay. So first, how many people are there total? 5. Because Darnell, it's 113 to 118, Sailor. It's Darnell and his 4 friends. So that's 5 people. So that's how we get the 5 right here. And then each of them are paying how much? 17 bucks each. So, you know, we could easily just stack these up like some of you have probably been taught, like so. Oops, not like that. 17 times 5, and we could probably go to town on that and do it. Some of you did it today. Some of you, I don't know if you did do it today or not. I graded the Google form, and we missed these questions. So it says you can build a model, and in a way, building a model like this is probably not going to work for you because it's kind of big and it's a lot, but we're going to use it for today's sake. You'll see tomorrow it'll be a little different. What they have done is, you guys remember when you do math problems and you have like this number right here, and I say do expanded form? And how would I do expanded form? You know, that's where you do the plus, the plus. What would be the first number we're going to use over here? Ray says 1,000. What are we going to use in this second one? 200. What about the third one? 30. And then the last one? So what you're basically doing is you're taking this number here, the 17, and we're doing that. We're splitting it up. So we're looking at it, we're saying, well, there's 10 plus 7. That's all he did. You don't have to split the 5 up because 5 is pretty small, right? That's all you got to do. And now we multiply these partial products. We just take, what is 10 times 5? So that's where the 50 is going to go there. And now you take this 5 times the 7. What's 5 times 7? Remember how I say get rid of, so there's 50. Well, now we're going to bring math. We're going to add addition back into this. What's 50 plus 35? 85. So the total cost for the ice skating and sandwiches was $85. All right, so it's a lot, It'll help some of you. Trust me, it will. Now, we may not make the boxes like they do, but we'll make them one way, and I'll kind of show you it's easy. When you use partial products down here at the bottom, you're using a property. A property is a rule in mathematics that can be applied to all numbers. The property that you applied above is called the distributive property. We distributed this 5 amongst the 10, and we distributed amongst the 7. It's like me having a stack of papers, and I have to give you 5 pages, all of you, each of you 5 pages. I'm going to go and I'm going to distribute 5 pages to each one of you. I'm going to distribute that. So that's kind of what we're doing here. Turn the page. Try it. 7 times 56. Now, if I were doing this, I wouldn't use a model like this. I would do a model like this. I would just draw that. Okay? Now I'm looking at these two numbers right here. Which digit there has only one digit in it? Emma, which one has one digit? Look again. Which number has only one digit? 7 or 56? Which has one digit in it? 7. So I'm going to put that 7 right here. Because look, there's only one space here for it, right? Now we're going to split the 56 up. How would we do expanded form on 56? 50 and, okay, right there. Everybody understand that's how we got 56, 50 and 6? We just did expanded form on that. Now we're going to distribute this 7 amongst 50, and we're going to distribute this amongst 6. Let's do the 7 and the 6 first. So what you do is you take your fingers and you run it along here until they meet, and that's where your answer is going to go. So what's 7 times 6? That's why we're doing the times tables. 42. Put 42 in this box. Now we do, what is 7 times 50? We run our fingers, and that's where we're going to put the answer here. What's 7 times 50? 350. Because 7 times 5 is 35. We add the 0. Now we just add these up. 350 plus 42. So what's 350 plus 42? Colton. 392. So the answer is 392. Now again, if you know how to do it this way, I still want you to practice using the distributive property today because it will help you guys out when you get in middle school math and learning how to do distributing. But it would be 2, we put the 4 up there, it'd be 392, and I was done. I didn't have to do all that work. But again, this just shows you kind of like what they're doing right here. 7 times 50, 7 times 6. Now, you don't even have to draw the box if you don't want to, and I'll show you how to do that in a second. You done? Okay. We're going to skip these. Let's go ahead and go to the assignment here so we can really get into it. Now, I'm going to show you both ways. The way I would do it if I had to use the models. And then I'm going to show you the way if I just use writing it out. So which one of these two numbers here only has one digit in it? Ireland. So put the 4 in this box right here. Let me use blue. Can you see blue better? I don't know what I did with my blue pen. Guess we're using this one. Oh, there it is. All right, so now we need to take 16. How are we going to expand 16? How are we going to expand 16? This is the part we need to make sure everybody gets on how do you expand 16. Lauren. Now we're doing 16. So how are we going to do 16 in expanded form? Ray? 10 and 6. That's the same as 16, right? We took this 16 and we said there are 1 10 and there are 6 1s. That's how we did it. Now we're going to distribute 4 times 10. What's 4 times 10? And then we're going to take 4 times the 6. What's 4 times 6? Good. Now we add these up. What's 40 plus 24? Now, if I were going to write this out not using the graph, the chart, I would say, okay, 4 times 16 equals. I know that I'm going to need 2 sets of parentheses because I'm going to add these up in the end. I'm going to do it like it kind of looks like an owl's face, don't you think? The eyes, and then we have the little nose here in the middle. Kind of looks like an owl. You guys see that kind of? I've always thought that looks like an owl. All right, so we're going to put a 4 because this is our 1 digit. We're going to put the 4 in both of these, like that. Now we're going to take this 16 and we're going to split it up. What did we split it up as? 10 and 6. And we're going to multiply inside these parentheses right there. Now, what is 10 times 4?
40.
Plus, what's 4 times 6?
24.
And then we get, that's our answer. That's our answer, 64. Okay. We'll practice on this method right here because some of you, this isn't going to work for you. It's too easy. This shows you some algebraic stuff that you're going to need to know later on. Let's do 6 times 81 now. What's our single digit? Somebody else, Ireland, I appreciate you. Go ahead and get a sucker over there. Because you raise your hand every single time. Every time. And I appreciate it. Somebody else. What is our single digit up here? Colton Johnson, what is our single digit? The one that only has one number. 6. So we're going to put the 6 right here, right? 6. All right, now, let's get Asher Owens, 81. How are we going to expand 81? What? And then what else? Good job, Asher. So now we need to distribute. This is 6 times 80. This is 6 times 1. That's easy. What's 6 times 1?
6.
What is 80 times 6? 480. Good job, Holly. 480. And we add those together, you're going to get what? Good. So let's do that other problem over here. 486. So we're going to rewrite 6 times 81. I highly recommend doing this because some of you might think this is easier. We're going to make an owl's face plus. We're going to put a multiply in here like that. We just gave him eyes now. Dead eye. Yeah, he's a dead owl. Draw your dead owl on there. All right. And then we're going to put a 6 in here because that's our single digit. And then how do we split up 81? 80 and 1. Now let's do the multiplication on that. What's 6? We already said 480 plus 6, which equals, I'm telling you guys, this right here, this is middle school stuff. Eventually this will be, they'll have a letter in there. It might be like X times whatever, but it's getting there. Or 4X times. All right, let's do number 6 now. Emma, what is our single digit on this number 6? So we're going to put the 7 right here, right? Now, how do we split up 29? Libby, how are we going to split 29 up?
What?
How are we going to split 29 up? How are we going to expand it? Look at this one here we did. 81, we did 80 plus 1. This one right here, 16, we did 10 plus 16. Sailor, what do you think? 20 plus 9. Yeah, 20 plus 9. Again, we saw that there are 2 10s, so we put 2 times 10 is 20, and then we have 9s. So let's do 7 times the 20. 7 times the 9. So what do you get when you get 7 times 20, Ireland? And what do you get when you get 7 times 9? 63. We add these together, and what are we going to get as a total? Something like that, right? There you go. So 203. Let's do it my way over here. We have 7 times 29. We're going to draw our dead owl. Y'all get the way it looks like it, right? Kind of looks like. Hey, Mikey, scoot back a little. So we're going to put our single digit, our 7, we're going to put right here on both these spots here. We do the same thing every time. Put that right there. And then we're going to split that 29, which we already did over here. We said was 20 and what? And then Ireland already told us that was 140. And then Asher told us this was 63. And then I told you it was 203. Boom. We just checked it two different ways. Now, who wants to try number 7 all by themselves? Now, we can't do it up there because I didn't record the screen up there. So, Holly, walk us through it. Loudly, if you could. Good, so she said that. Nope. There you go. Good job. You might want to try doing it the other way. All right, Asher, go ahead. Tell me what to write. The owl face? Good. Good job. You guys just solved those 2 different ways now. Let's do a word problem just so we can get familiar with using these in word problems because they do use them quite often. Ronnie swims 4 laps each day at the pool. How many laps does he swim in 28 days? So basically, what's the multiplication problem they're giving us here? Lauren? Okay, that's the multiplication problem. Now we're going to use, you can either use the if you want to draw the little thing over here, I'm not going to require you to use both. Which one do you guys want to use? Raise your hand if you want to use the box. Raise your hand if you'd rather use the other way, the algebraic way. All right, so who wants to walk me through the algebraic way, the way that Asher did it? Ireland, you had your hand for the other one. What do we do now? Okay, just remember there's a plus in the middle, and these are 2 times, so go ahead. Okay. Yep. $112. Yeah, your answer is 112 laps he did. Yoshi saved $5 each for 23 weeks. What is the total amount of money he saved? Now this one says use an area model. So this one actually tells us that we have to use the box, which we'll just draw the box right here. How about that? We're going to be crammed for space here, but all right. I did that incorrectly, didn't I? Sorry. We'll do it over here. There we go. All right, so what are we going to put? Someone want to walk me through this? We're not using this one here or this one here. We're going to use this one right here. What's our multiplication problem we're going to try to figure out? Come on, one of you. Come on, one of you. Come on, Gavin. Walk me through it. What's my multiplication problem for number 9? Okay, 5 times 23. So where are we going to put the 5 at on this chart, Gavin? The side of it right there. Now what are we going to do with the 23? So how do we split it? Okay, 20 and a 3 like you said. Now what? Okay, so what's 5 times 20? 100, yeah. And then you said 5 times 3 over here. What is that? And when you add those together, what do you get? 100 plus 15 is? Anybody? Asher? Yep, 115. So he saved 115 bucks. Yeah. Anybody have any questions? You know, I would definitely take this sheet here as you're doing your homework. And if this way is easier for you, go ahead and use that. Go ahead and use, if that way right there is easier and you understand it, use it. If you'd rather use the boxes, use it. Now, eventually we're going to have to get to where you're just going to do 29 times 7 like that. Eventually. But for right now, we'll practice on that, yeah. Oh, thank you. All right, so your homework, before I give it out to you, you have number 1 here. It says use an area model. You can use either or. I don't care. This one right here says use an area model. Again, either or. Don't care. I don't care on any of these which ones you use because it says use area model for all of them. I figured, hey, they taught us this method here. Let's use it. This is an area model. This is just a distributive model here, okay? Just a regular old algebraic. This one right here, you're going to write an expression. So basically that one right there is this one right here all over, just that one right there. So this should be fairly easy if you need me. You know, I'll be helping you here. So that's it. Homework is page 117 and 118.